This video will discuss chapter 11.5, Polygons. So a couple of slides I probably ought to have you write down. So this first one is going to talk about the number of sides and the name of the polygon. That should be a 10. It's kind of like a 16. So a polygon with 3 sides is a triangle, with 4 sides is a quadrilateral, 5 sides is a pentagon. There's a very famous pentagon in Washington, D.C. 6 sides is a hexagon, 7 sides is a heptagon, 8 sides is an octagon. That's a shape that's become very popular now that MMA is becoming popular, and that's the shape of the ring, obviously. It's called the octagon. 9 is a nonagon, and 10 is a decagon. You may want to pause the video at this time and make sure that you have this chart copied down. This is a chart that we are going to use repeatedly for the next couple of weeks. Secondly, I would make sure that you have this formula written down. And so this is how you find the total degrees of the interior angles of a shape. And so it's n minus 2, and n is the number of sides. N minus 2 times 180 will tell you the total number of degrees inside of a polygon. I'm going to show you what this looks like or why this happens in just a second. You may want to pause the video at this time and write down this formula as well, since we're going to be using it. Alright, so we're going to use this formula. I want to show you how it is that this formula actually works or came about. And so if you take a look at like a quadrilateral or a rectangle, which obviously is a quadrilateral, you'll notice that if you were to go from one angle, we'll just go from this angle and draw the diagonal, you will cut this in half, right? But you create 2 triangles. And as you know, each triangle has 180 degrees. So this is 2 triangles times 180. This would be 360 total degrees inside of a quadrilateral or inside of a rectangle. And as you know, a rectangle has 360 degrees. So that makes sense and obviously kind of helps prove the point. If you look at this shape, which is a pentagon, 5 sides, 1, 2, 3, 4, 5, and we're going to go out of this angle, and I basically draw the diagonals out of this angle. You'll see that I'm able to cut this into 3 triangles. Each triangle would have 180 degrees, so the 5 minus 2 gives me 3. 3 times 180 is 540. There are 540 total degrees inside of a pentagon. And then a hexagon down here is 6 sides, and if I draw the diagonal out of one of these angles, you'll see that I got 1, 2, 3, which means that I'm going to break this into 4 different triangles. The 6 minus 2 gives me 4. 4 times 180 is 720, and so there are 720 total degrees inside of a hexagon. So you're basically in the number of sides, you're subtracting 2, but really what you end up finding out is that there are either 2, 3, 4 triangles inside of that figure, each triangle having 180 degrees, and so you're multiplying times 180 to figure out exactly how many degrees are inside of the shape. Okay, so that's where this formula is coming from. It's not some magical formula. If you take the number of sides and subtract 2, you're going to end up finding out how many triangles. Okay, and so an interesting project or something you may want to think about if you enjoy challenging yourself is, why is it that if I subtract 2 from the total number of sides, it will tell me how many triangles are inside of that shape? Alright, and so let's take a look at a problem like this one. What is the measure of one interior angle of a hexagon? So we're going to end up using this formula. But remember, this formula is going to tell us how many total degrees are inside the hexagon. And this one, we want to know how many in one angle of a hexagon. So a hexagon has 6 sides. So I'm going to go 6 minus 2 times 180. So this is 4 times 180. So I know that there are 720 degrees inside of a hexagon. Okay, but that's the total. I want to know how many in one interior angle. So if you look at a hexagon, we actually have one drawn here. You'll see that there are 1, 2, 3, 4, 5, 6 angles inside of the hexagon, just like there are 6 sides, right? And so one good thing to know is that the number of sides and the number of angles inside the shape is identical. And so I'm going to say, well, okay, if there's 720 total degrees, and I want to figure out how much one of those angles is, I'm going to take the 720, I'm going to divide by the 6 angles, and I'm going to end up with 120 degrees. So each angle inside of a regular hexagon would be 120 degrees. Alright, that's all I got for you today on polygons. Thanks very much for watching the video. Don't forget to do the problems on the bottom of the page. I'll see you in class.